Hello. So this is a guide video for quiz 4. So the first question, as usual, the order of the questions can be different in your quiz, and also the numbers may be different in your quiz. So what I show you is just one uh, set of questions that I happen to get. So keep that in mind. Don't just copy my answer. First question. Kansas City Chiefs quarterback Patrick Mahomes, like one MVP, and in that season, his passing yards in 16 regular season games are given below. This is real data, right? So maybe we can update the data to 11 game season. Anyhow, so find the range of his passing yards. Idea is simple. We are going to calculate the range by finding the maximum and the minimum. So all you just need is to look at the numbers and find the maximum number and the minimum number and take the difference. That is the range. This is it. So it is pretty simple, but when I do this, it's pretty confusing. Where is the maximum? Where is the minimum? So maybe you can just copy the numbers to Excel and then it will be more automatic, but it may take more time. Okay, it's simple. Second question. A group of students took tests on reading and math. Following show summary statistics for each subject. So reading and math data are given, like different summary statistics are given. Sample size the same. And among the following three statements, choose all correct statements. So of course, in your options, you have like 1 or 2 or 1 or 3. So you have to choose the right statements. So let's see one by one. Number 1, because the mean is much higher than the median in math, there must be some outliers who got exceptionally bad scores in math. So the first part is correct. Because the mean is much higher than the median, there must be some outliers. Up to this point, the statement is correct. But the problem is, outliers are not on the bad side, but on good side, right? So median, here, compare the median and the mean. Mean is much higher than the median. Mean is higher than the median. That means there are outliers who are dragging up the mean more than the median. So the mean is more sensitive to outliers than the median. So higher mean implies that there are outliers that have very high, large numbers, right? So this part is wrong. So the correct statement should be there must be exceptionally good scores in math. So that's why the mean is greater. So it's skewed to the right. Okay, that is an error in the first statement. And second, reading scores have a smaller interquartile range than math scores. You can calculate the interquartile range by looking at the first quartile and third quartile. So compare them, and then you will get, you can calculate the interquartile range by subtracting them, right? So then math has higher interquartile range. So and reading has a smaller, so this is correct. Okay. Third, reading scores have a smaller variance than math scores. Even though variance is not given in the table, but basically the variance is standard deviation squared. So if you compare standard deviation, then you can conclude which has smaller variance, right? So because reading has smaller standard deviation, that implies reading has smaller variance too. So this is also correct. So the second and the third statements are correct. Okay. Okay, from this question, I'm going to show you many exercises, very tedious algebra exercises to calculate the variance, the standard deviation. If you are good, then you may skip that. But I will go step by step. So in this question, the finishing process on new furniture leaves slight blemishes. The table below displays a manager's probability assessment of the number of blemishes in the finish of new furniture, right? So there is like 4 possible outcomes, 0, 1, 2, 3, and the probabilities are equal, right? Simple. I was lucky to get very simple numbers and determine the variance of the number of blemishes. Okay, let's do this. We have probability distribution table. So the first step is to calculate the mean based on the probability distribution. So easy, it is easy. Outcome is 0, 1, 2, 3. Probability 0.25 for each of them. And then multiply outcome to the probability to obtain the weighted outcome. So you get 4 weighted outcome row by row, and then sum up the weighted outcomes in this column. So then you are going to get 1.5, which is the mean. The mean is 1.5. Okay? And then, but using this mean, you calculate the square deviations. So if you get outcome 0, the deviation is minus 1.5. Subtract the mean, and subtract 1.5, then you get minus 0.5. And 0.5 and 1.5, these are deviation from the mean for each outcome. And then you square them. Square these guys. Then you are going to get these numbers. So this is a process of transforming a random variable from the original outcome, number of blemishes, to squared deviations. So you get these 4 numbers. And the next step, using the new random variable, square deviations, with the original probability, calculate the mean, right? Square deviations, probability, and multiply them. This, maybe you can open Excel and copy these numbers to Excel and do the algebra on Excel. So multiply this number to the probability, this to this, like that. You get 4 probability weighted squared deviations. And then add those 4 numbers. You are going to get 1.25. That is the variance. Here, there is no difference between sample variance or population variance formulas because we have probability distribution. In that case, just take the probability and there is no other formula. So you don't need to worry about which formula you are using. Okay. Next example, an email with a link to a customer satisfaction survey is sent to all customers to an auto repair shop. Suppose that the survey asks whether the customer is satisfied and there are only 2 answers, yes or no. Let X be the random variable that denotes the answer from a customer. It takes 1 if the answer is satisfied and 0 otherwise. It is known that 80% of customers answer satisfied to the survey. Determine the variance of the random variable X. Okay, let's so the original outcomes are satisfied or not, and this is not they are not numbers, so we cannot calculate the variance without changing them into numbers. So we change them into numbers, like the satisfied is labeled as 1 and not is labeled as 0. That is a numerical description of the outcomes, so it is a random variable. We call that X. Then you get a probability distribution. We know the probability of satisfaction. So 1 happens with 80% of customers and 0 happens 20%. And then it is easier. So calculating the mean is multiplying probability to outcome and sum. Then you get 0.8, right? So 1 happens with 80%, 0 happens with 20%. So it is natural to have a mean of 0.8. So using the mean, you need to calculate the squared deviations. Outcome minus the mean. So 1 minus 0.8 equals 0.2, which is the deviation, and 0 is 0.8 below the mean, so the deviation is minus 0.8. And then square each of the deviations, so 0.2 times 0.2 equals 0.04. Minus 0.8 squared equals 0.64. These are square deviations. And you know what to do in the next step. Calculate the mean of the square deviations. So square deviations use the probability. So 0.04 happens with probability 0.8 because this square deviation comes from the customers who are satisfied, and that probability is 80%. So you multiply them, and weighted outcome should be 0.032. And square deviation 0.64 happens with 20%, so their product is 0.128. Add these two numbers, then you get the variance. The variance is 0.16. Okay, so this is it. This is enough for this quiz. But by the way, I will just spoil what we are going to do in chapter 5. In the next chapter, we are going to learn this kind of random variable. It is called binary random variable. And this variance could be calculated as 0.8 times 0.2. So probability of, if you multiply these two probabilities, you are going to get the variance. So that is a property of binary random variable, which we are going to learn next week. Okay? Coming soon. The next question. Following is a distribution table for the number of coffees per order from randomly chosen 200 mobile orders, right? So at Starbucks, for example, a mobile order, 75% of 75 out of 200 mobile orders had only one coffee, and another 75 had 2 coffees, and 3 coffees or 4 coffees. So we have frequency distribution table. So you can expect that the first step should be converting the frequency into probability. And we need to find the standard deviation. Okay. First, I will convert frequency to the probability. We know the sample size is 200. So out of 200, 75 equals 37.5% or 0.375. Likewise, we can keep going. So divide the frequency by the sample size 200, then you are going to get probability like this. And then to calculate the mean, you have to multiply the outcome to the probability. Multiply, 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 multiply. 4 times 0.125, 3 times 0.125, 2 times 0.375, 1 times 0.375. You get 4 probability weighted outcomes, right? And add these numbers, then you get 2. So simple. Intentionally I made a simple number, right? The mean is now 2. Then it is easy to calculate the deviations. So subtract 2. So 1 coffee is less than 1 coffee less than the average, and 2 is 0. 3 is plus 1. 4 is plus 2. So square them. 1, 0, 1, 4. Pretty simple. Okay. And this is transformation. And then step 3, we are going to calculate the mean of the squared deviations. So square deviation is given 1014, and attach the original probability, and then you have to repeat calculating the mean, multiplying the square deviation to the probability, and do that for each of the square deviations, and sum all the numbers, all the probability weighted square deviations, and you get variance. One is variance here, and what you need is standard deviation, which is the square root of the variance. So again, it is still 1. Okay, that is how we calculate the standard deviation. Okay, let's go to the next question. After reviewing your wireless data usage record for the last 20 months, you found that the mean of your monthly wireless data usage was 500 megabytes and the standard deviation was 50 megabytes. Suppose that your wireless data plan charges you a fixed monthly fee of $10 plus a data usage fee of $0.1 for each megabyte you used. For example, if you used 100 megabytes, you pay a total of $20, including the monthly fee of 100, $10, and the data usage fee of $10, which is calculated as 0.1 per megabyte times 100 megabytes. Find the mean and standard deviation of your monthly payment. So let's understand the question. We have distribution of our data usage, but in the end, what we want is payment, dollar amount we pay. Okay, so it involves a transformation of the random variable, but it is clear that the transformation is linear. So you are going to add $10 and multiply 0.1. So 0.1 is multiplied and then add $10. So it is a linear transformation. That is the key idea. Okay, and you know the mean and the standard deviation of the original random variable. Let me summarize what I just said. I define x as the original random variable, wireless data usage in megabytes, and x is megabytes, and y is monthly payment in dollars, of course. And then what we know is the expected value of x is original variable's mean is 500 megabytes, and standard deviation 50 megabytes. Okay, this is what is given from the question. And we also know that if y is a linear transformation of x, then you can say, then you know that the expected value and standard deviation of y can be written in this way, using the original variable's mean and standard deviation. Okay? So then now we apply this linear relationship to our specific case. We are multiplying 0.1 and add $10, right? So for each megabyte, you pay 0.1 and plus a fixed cost of $10. Okay, it's the linear transformation, perfect linear transformation, and then you can use these formulas. Expected value of y, it preserves the same relationship with the mean of original random variable. So plug in 500 here, then you will get the answer. It's pretty simple. Plug in 500 here, and standard deviation is not affected by plus 10, but it's only multiplied by 0.1, right? Absolute value of 0.1, but anyhow 0.1 is positive, so 0.1 times 50 megabytes is the standard deviation of y. So it will be pretty straightforward if you understand the linear transformation. Okay, from now on, this question and the following questions are using numbers, raw data. They don't have a probability distribution table. I just give you several numbers, and then you have to calculate the variance or the standard deviation. And in doing that, what you have to be more careful is that which formula you have to use. So I'm asking you to find the sample variance formula. Sample variance. So you are going to use sample variance, which means the denominator is n-1. The sample size minus 1 is the denominator. Okay. Okay, let's see. An Amtrak official obtains data on a particular day concerning the length of time in minutes that the metro liners leaving New York take to reach Philadelphia with the following results. So 91 minutes, 88, 92, 91, 89, 89. So 6 trains, time to arrive at Philadelphia, and variance. To calculate the variance, as before, we are going to calculate the mean, which is just like this. Add 6 numbers, divide by 6. By the way, so even though we are using the sample variance, the denominator for the mean does not change. It's just mean. Mean has no other formula. So this is the mean. And using the mean, we are going to calculate the squared deviations. There are 6 observations, and you calculate deviations by subtracting 90, the mean, and then square them. Right? Pretty easy numbers. So we have 6 squared deviations, right? So then in step 3, we have to calculate the mean of squared deviations for the variance. But we are calculating average of them. This is simple, but what you have to be careful is the denominator. We are using sample variance formula. So here comes n minus 1. So 5, it should be 5, not the sample size. So the variance is 2.4 using the sample variance formula. So basic steps are the same, but this is the only minor difference. Okay. Maybe this is the last question. One of the most common standardization methods for test scores is to measure how far test scores deviate from the mean in terms of standard deviation. So the distance from the mean is divided by standard deviation. Mathematically, if m and s are the mean and the standard deviation of test scores, a test score of y will be standardized to y minus m divided by s. Okay, this is the typical standardization method. For example, if 105 are the mean and the standard deviation, then a score of 112 will be standardized to 112 minus 100, which will be 12, divide that by 5, which will be 2.4. So that's standardization method. Now you observe 6 test scores like these, and then given these test scores, you have to calculate the mean and the standard deviation, and then standardize a score of 70. 70, how can you standardize that? And there are several hints, like use approximate, like like even if you use calculator, it will be the same. I'll just giving you some hints. And round to the second decimal place, and use sample variance formula, right? Use sample version formula for both variance and standard deviation. Okay. Okay, then again, the first step is to calculate the mean. So easy, 6 numbers, add and divide by 6. Again, the denominator is just 6, not n by 1, n minus 1. So mean, it is easy to calculate the mean. And you can calculate square deviations using the mean. Mean was 80, so subtract 80 here. Then you get these deviations, and then square them. Then you get 6 observations of squared deviations. Then next, you calculate the standard deviation, but using the sample version formula. So 6 numbers added, but divided by 5, not 6, because we are using sample version formula. Then you will get 150. This is the variance. This is the mean of mean of squared deviations. And finally, standard deviation is the square root of that. So square root of 150. And in the question I gave you, in a hint, I gave you an approximate number. Use that. And then finally, using these numbers, you have to standardize 70 to this number, like in this form. Subtract the mean, divide by the standard deviation. Using a calculator, it gives you minus 0.816 something. So it means that if you get a score of 70, that is below the average by 0.8 standard deviation. So that much is the distance, relative location from the mean. Okay, thank you for watching. This chapter involved more algebra because it was variance, but it's not that bad. Thank you for watching here, and next chapter will be a little bit different. See you next week. Bye.